Dear friends, good morning. We will start our discussion on the content of the engineering physics for the B.Tech first year. In that syllabus we have first unit as the theory of relativity. So in this lecture I have planned that we will discuss the basics of theory of relativity. Number 2, we will discuss that what are the frames of references, and thereafter types of frame of references. Obviously there will be two types of frames of references. One is the inertial and other is non-inertial. Then we will have the transformation equations. And then we will discuss Galilean transformation equations. This much we will discuss today in this lecture. As we know that the theory of relativity means for the relative measurement of the things. In this universe, nothing is static, everything is moving. That's why the measurement will be relative to each other. For example, if we are talking about the solar eclipse, that is also the cause of relative motion of the earth and sun. Similarly, if we will take other phenomena, for example, a person is moving in this direction and other is moving in this direction, then how their velocity will be related to each other, that we can discuss in terms of the theory of relativity. As we know that the theory of relativity tells us that the fundamental units remains no longer constant and they will vary with respect to velocity. If we will have the more velocity, then the fundamental units remains no longer constant. Even if we will talk about the mass, or we will talk about the time, or we will talk about the length, or other fundamental units remains no longer constant. Subject to the condition, these measurements should be in that frame of reference where the velocity of the reference should be very high in comparison to the classical mechanics. So here we will see these things we have depicted in our slide. Success and failure are the relative in nature, just like rest and motion. This is the code related to the theory of relativity. Here, as far basic concept of the theory of relativity is concerned, as already I have stated, that all the measurements in this universe are relative. According to the special theory of relativity, the fundamental quantities, that is space, time and mass, remains no longer constant, are invariant, but it depends that what is the state of motion of these quantities. The theory of relativity predicts the Newtonian mechanics is one of the limiting case of the theory of relativity. Special theory of relativity means that if we will come to the Newtonian mechanics, then the velocity will be very less in comparison to the special theory of relativity. Later on we will see that the theory of relativity deals with the way in which the observer in the relative motion describe the physical phenomena with respect to one another. Here we have the statement of two great scientists. One is the Newton and other is the Einstein, and both are the great scientists which are discussing the classical mechanics as well as the special theory of relativity. As we know that the Newton was the pioneer in the classical mechanics and Einstein was the pioneer in the special theory of relativity. There is a fundamental difference between the suggestion what they have taught to the community or what they have suggested regarding to the space and time. You will see here that Einstein discovered that there is no absolute time. It too depends upon the state of motion of the observer. Means that before the Einstein, it was considered that the space and time both are independent to each other. There is no link, there is no relation, no dependence of the space as well as of time on each other. So initially what Newton suggests that space and time both are completely different concept, but very soon Einstein suggested that space and time are two different aspects of the same thing. As today we will discuss that the concept of theory of relativity means that depends that what is the position of observer, where the event is occurring, what are the parameters which will be used to define a particular event completely. The complete information of an event can be obtained by knowing the facts about where the event is occurring, what is the time of occurrence, and who is regarding the data regarding to that particular event. For example, if we are saying that if we have this particular event which is occurring at this position, then anybody will say that what is the position where the event is occurring. Then where means obviously this where refers to the x, y and z coordinate, that is the space where that event is occurring. Second, next question will be where that event is occurring, means that what is the time of occurrence when that event is occurring, that is the time. And next point will be who is observing that particular event, means that who is recording the data for that particular event. So that will be the observer. Observer means that if we will focus on these three W, then we will have the complete information for a particular event. Means that where is the event, when is the event, and who is observing the event. If we will keep these two information together, then we will have x, y, z and t. This is the complete information to know about the event, where it is occurring and when it is occurring. So next point here, according to the choice of the position or the reference frame, same observer may detect the same event in the different way, as by being at the center of a wheel or on the ground, the mark on a moving rim will appear in the different way. For example, you will have this rim, and on this rim we have a particular mark. This mark has to be observed by the observer. One chance is that our observer is at this center point, and other chance is that observer is here outside this rim. then for this observer this will appear just as a circle, and for this observer when it will be at ground, the motion of this ring will be just as the cyclide, as already has been depicted here. If a person or the observer will be at the center of this ring, then it will appear just as a circle, and if the observer will be outside, that is on the ground, then the motion will be appear in the form of cyclide. As far frame of reference is concerned, because to measure the information for any particular event means that either that is the event or that is the position of a particular thing, we must have a particular coordinate system with respect to which we used to measure the information, we used to measure the space, time and all things related to that particular event. So for that, obviously there should be a coordinate system. This is a coordinate system. This coordinate system will be considered as a frame of reference, provided that it should have its fixed position. It should have its fixed position, means that it has not to move here and there, because it will be as a reference point for our measurement. Means that's why it has been stated that a coordinate system must be fixed with a rigid body, means that that has not to move here and there. And with respect to that, we can measure the position of this particular event, and we will say that this is x, y, z, and if we will also include the time coordinate, then the complete information for this particular event will be x, y, z and t. Means that frame of reference is a coordinate system which is attached with a rigid body and used to measure the information for a particular event or a thing. Just already I have discussed here, here P is a point, R is the radius vector, X, Y, Z are the three axes which will measure the position of this particular point. So as we were discussing here, this is the frame of reference. Frame of reference means that coordinate system attached with the rigid body, and R is the radius vector that gives the information for the position of this P, and this R include the information along x-axis, along y-axis, along z-axis. So for example, if we are taking this particular figure here, and x we are taking here, y we are taking here, z we are taking here, then the depiction for the position of this one will be in this way. Means that how much distance it has been covered along this y-axis, that will be y, and what the distance it has traversed along x-axis, that will be the x, and what is the distance along z-axis. So according to that, we will have the position of this particular point, that is P, X, Y and Z. If anybody is including that what is the time of occurrence, then that has been also included here, and hence the complete information for P can be given as X, Y, Z and P, T. These frame of references are classified into two categories. Number one is the inertial frame of reference, and other is the non-inertial frame of reference. Our student has a confusion regarding to the inertial frame of reference and non-inertial frame of reference. Let us see it very carefully, as well as it's very simple to distinguish between the inertial as well as non-inertial frame of reference. So let us take one by one. Inertial frame of reference. In this we will see that the inertial frame of references are those frame of references in which the Newton's laws holds good, as well as in this frame of reference, if any body is there, any particle is there, any event is there, the position of that event particle that is not accelerated means that no external force is applied on that particular body or the event or the point. So, in order to discuss in a better way, let us consider a frame of reference, which already I have discussed that what should be the beauty and what should be the characteristic of the frame of reference. That should be attached with a rigid body, and here we are taking this particular point or a particular body. If this body is not experiencing any external force, then this frame of reference will be known as the inertial frame of reference. Means that if there is no force on a body, it means that this F will be equal to 0. If F is equal to 0, then this F is equal to m into A. A is the inertia of a body, that will not be 0. Definitely this A should be 0. So F will be 0 when this A is equal to 0. This implies that this is unaccelerated frames of reference in which Newton's laws has to be holds good. In inertial frame of reference, a body does not experience any external force, what I have stated here. Therefore, its acceleration A is given by expression that A is equal to d2 r upon dt2 is equal to 0, and F is equal to ma, that is equal to 0. Already I have discussed this m is the inertia of a body, that will never be 0. Means that if we have to put this F is equal to 0, then A will be equal to 0. Here we have the inertial frame of reference. For that, here you will see two frame of references. One is S and other is S dash. Both will be treated as an inertial frame of reference, subject to the condition that S dash has to move with a constant velocity v with respect to S. Means that if we are taking another frame of reference here in this way, and this is parallel to this and this is in this direction, so this we will say that this is S dash and this is S, and this frame of reference is moving with a constant velocity v. Obviously we will have the observer O and observer O dash here. By being in S frame of reference or by being S dash frame of reference, we may have the different observation for this particular event. If the observer of S frame of reference supposed to answer about the position of this point, let this point is P, then he or she will say that is X, Y, Z and T. At the same time, if O dash will be asked that what is the position of this particular point, then it is X dash, Y dash, Z dash and T dash. These are the information. What should be the relation between these points? In order to have the idea about that, let us join these points by the vectors in this way. These are the vectors, and if we will join this one, then this will be the vector triangle. Initially, when t is equal to t dash is equal to 0, this frame of reference is coinciding this frame of reference. But when second frame of reference is started its journey with a constant velocity with respect to the s, then in a time t, this much distance will be traversed by the second frame of reference. And if this is the radius vector regarded by O dash, then we will see it as this is R dash, and this has been regarded by O, then this will be equal to R. If we will write the relation between them, this will be relation that R, vector R is equal to R dash plus Vt, this will be. Now let us have the differentiation of this equation with respect to t. Then this is dr upon dt. This is equal to dr dash upon dt plus v. If we will have differentiation once again, then we will have d2r upon dt2 is equal to d2r dash upon dt2, and both will be equal to a is equal to a dash, and for the inertial frame of reference essentially it is required that the acceleration must be 0. That's why a is equal to a dash is equal to 0. If these conditions are fulfilled by these two frame of references, then they will be in the category of inertial frame of reference. Now let us have the second type of frame of reference, that is non-inertial frame of reference. This is an accelerated frame of reference in which the Newton's laws do not hold good, are called the non-inertial frame of references. Suppose that S is the inertial frame of reference and another frame S dash is moving with an acceleration a0 relative to S. Then the acceleration of a particle P on which no external force is acting will be 0 in the frame S, but in frame S dash the observer will find that an acceleration minus a0 is acting on it. Thus the frame S dash, the observed force on the particle is minus ma0, where a is the mass of a particle, and such a force which does not really act on a particle but appears due to this acceleration in that frame is known as the fictitious force or the pseudo force. Let us have the little bit discussion on this point, because when we are saying that there is the fictitious force, there is the acceleration experienced by the particle by being in the moving frame of reference, even the force has not been applied on that particular particle, how it can be grasped here? For that, let these two frame of references in this way, these two frame of references, similar to the earlier case what we have discussed, but the difference is that this is moving with the accelerated motion. This S dash is moving with the accelerated speed. Here we have O and here we have O dash. Now we have a particular particle here P. This P is here, and the position of P can be measured by the observer O and O dash respectively, and the information for this will be given as x, y, z, t, and x dash, y dash, z dash, and t dash. But this case is slightly different to the earlier one. What is that? This frame of reference initially at this position, when t is equal to t dash is equal to 0. Then this frame of reference is this frame of reference was lying on this one. But when it has started its journey in this direction, then that journey will be accelerated. And if particle have its fixed position here, then two things can be considered. Either this frame of reference is approaching to this particle with a particular acceleration, let that acceleration is a0. But if we are saying that let this frame of reference is fixed and this particle appears to move in this direction, then minus a0 will be experienced by this particle P, and this minus a will give a force. That force will be equal to minus A0 multiplied by the mass of a body, and this minus MA0 is known as the fictitious force or the pseudo force which is acting on P. Why fictitious? Because actually the force has not been applied externally to this point, but since it was moving with the acceleration, so obviously with this acceleration, if we are putting this frame of reference is constant, then it seems that this P is approaching to this point with the same acceleration but in backward direction, and this backward direction will give a force. That force is known as the pseudo force, having its magnitude minus m into A0. So this is the basic fundamental difference between the non-inertial frame of reference and inertial frame of reference. Means that actually there is no external force on the body in the inertial frame of reference, means that no acceleration will be experienced by the body. But when we will talk about the non-inertial frame of reference, since S dash is moving with the acceleration, and if we will consider S dash as a static, then the relative motion will give the idea that P is coming towards S dash with the same acceleration but in negative direction. That's why the particle will experience the pseudo force, that is known as the that also known as the fictitious force acting on that. Here that fictitious force has been given by its magnitude. Already I have discussed this one. Now let us have some conceptual question, because in physics most of the time it has been experienced that if we are reading theory, then without solving the problems we never realize that what the principle says in really in the theory. So in order to have that conceptual question, we have this problem that calculate the fictitious force and the total force on a body of mass m if the frame of reference is moving vertically upward and vertically downward with the acceleration of 5 meters per second square. Means that very simple problem is given here, that we have this body, and this body have a particular mass, and that mass is equal to 6 kg. And one frame of reference is moving vertically upward direction and other is moving in vertically downward direction, and both have its acceleration as 5 meter per second square, in this case also, in this case also. So first let us calculate that what is the force acting on the body when there is no any frame of reference. Itself the body have its own weight, under its mass what the force experienced by this body, then obviously due to the gravity G will be applied on this one, then there will be the weight of body, and this weight of body will be equal to 6 multiplied by the acceleration due to the gravity, this acceleration due to the gravity. Here I have taken minus 9.8. 9.8 is the acceleration due to the gravity. Why minus I have taken? Usually in usual cases of the problems of the physics, we used to say that if we are throwing a ball in upward direction, then negative G has been considered. But here we are taking this minus sign for the downward direction. For the downward direction. So means that we will calculate this one, then this value will be equal to minus 58.8 Newton. And since this negative sign is there, that's why we will say that this is in downward direction. Downward direction. This is in downward direction. Now, this is the force acting on the body when there is no concept of the frame of reference. Neither the frame of reference is moving in upward direction nor it is in downward direction. Now we are taking the frame of reference here. In first case, we have to calculate the fictitious force acting on it when the frame of reference is moving in upward direction. Then in that case, what we will write here, that in first case we have the mass and the mass of this body, and what will be the acceleration on this body under the consideration of this frame of reference which is moving in upward direction. So for your kind information, if you will see that this frame of reference is moving in upward direction, then it seems that this particle is coming in downward direction. That's why we will have the negative acceleration, that is the fictitious force which will act on that body, and that we will write here mass multiplied by the negative of the acceleration which is acting on the body because of the frame of reference only. The force acting on the body due to its weight, that will remain as such, that will be universally applied in both the frame of references, but because of the motion of the frame of reference, we have an additional fictitious force, and that will have its value, that is equal to 6 multiplied by -5, and this will be equal to 30 Newton with the negative sign. It refers that this will be again in downward direction. So this contribution is only because of the motion of the frame of reference in upward direction, and already body have its weight, and that weight is in downward direction. Then the total value, both are lying towards the downward direction, then both value will be equal to the total value will be equal to 30 plus 58.8, and that is equal to 88.8 Newton when the frame of reference is moving in upward direction. Now let us see that if the second frame of reference is moving in downward direction, then what will happen? If it is moving in downward direction, then we will have the situation which is slightly different to the earlier one. Now we have the weight of body here, F is equal to mg, and that will be in downward direction, and that has been already calculated at 58.8 Newton. And since our body is moving in this direction, means that in downward direction, now this body will appear to come in upward direction, means that now we will have the positive acceleration corresponding because its direction in upward direction. Now because of the motion of the frame of reference in downward direction, we will have the mass of a body, that is 6 kg multiplied by 6 meter per second square, that is equal to 30, but it will be with positive sign and it will act in upward direction, and the weight of a body was acting in downward direction. That's why both will be in opposite direction, and the total force experienced by this body will be equal to 58.8 Newton. Since it is in downward direction, you may have the negative sign, and this is in upward direction, that's why we will have this positive sign, and finally we will have the 28.8 Newton with a negative sign. That negative sign means that this is acting in downward direction. So this is the concept corresponding to the fictitious force experienced by the body when it has been experienced or it has been seen in the frame of reference, in the limelight of the frame of references which are moving in upward direction or in downward direction with a certain acceleration. Let us have one more question. That question is here, if we are considering that Earth is inertial frame of reference. However, Earth is not inertial frame of reference because it have its rotational motion about the sun and it have its spin motion about its own axis. Question is here, the Earth revolving around its own axis is not an inertial frame of reference, obviously. If, however, we take it to be so, what would be the error involved in 1 second in the position of a particle close to the surface? The radius of the Earth has been given. Means that the problem is here. Okay. For example, we have the Earth here and it is spinning about its own axis, about its axis in this way, So here we have the situation in this way that this is the axis, then we are saying that this axis is in this way and this axis is here and this is revolving around this way. Now a particle has been placed near to the surface here. This is the when this particle will be near to the surface, then certain atmosphere of this Earth will be there, under which the body will also move with the environment of this Earth and the body will experience centripetal force on it. Due to that centripetal force, we will have certain centripetal acceleration or angular acceleration on that. That angular acceleration alpha can be given as alpha is equal to omega square into r. This omega square can be given as 2 pi upon t whole square multiplied by r, and this t is the time period in which this Earth rotates about its own axis, that is the 24 hour. That's why we used to write it as 2 pi upon 24 multiplied by 60 whole square multiplied by 6.4 into 10 raised to power 8 centimeter. This when we will calculate, then this value will be equal to 3.4 centimeter per second square. Since this particle is lying at the surface, very close to the surface of the Earth, the angular acceleration, that is the alpha, will be given by omega square r, and this acceleration will give the idea that if Earth has been considered as the inertial frame of reference, then in 1 second how much distance it will be displaced. So that we will calculate by the expression that s is equal to ut plus half at, u is equal to 0, initial velocity 0, that's why half into acceleration into t square, and that acceleration is this and multiplied by 1, and obviously this is equal to 1.7 centimeter. Means that what? If we are considering it as the inertial frame of reference, then 1.7 centimeter displacement will be there in the measurement of the position of that particle in 1 second. Now, what is the Galilean transformation? Equation. Before discussing the Galilean transformation equation, let us see that what are the transformation equation. For the basic concept of the transformation equation is here. If we have these two references, these are two frame of references. One is S frame of reference and other is the S dash frame of reference. Both are measuring the position of P in this way, that this is X, Y, Z and T. Other is measuring, means that O dash is measuring and O is measuring as X dash, Y dash, Z dash, T dash. Means that if This information has been revealed by observer O as well as by O dash. Then the relation between these coordinates is known as the transformation equation. Means that we can transform the information about a particular event or a point if we are knowing the relation between the motion of two frame of references, as well as we also require the data at least has been measured by one of the observer, either by being in this frame of reference or by being in this frame of reference. Now there will be a certain relation between x dash, y dash, z dash and t dash. These relations are known as the transformation equation. The most important effort was done by Galileo in order to establish the relation between the coordinates observed by the observer by being in the stationary and moving frame of reference respectively. Here you will see that we are taking two cases. In one case, simply moving frame of reference is moving in one direction with a constant speed. In other case, it is moving in all directions simultaneously. So here let us see this simple case. In this case, what is happening here? We are taking the point P here that has been observed by the observer O as well as the observer O dash. They will reveal the information for this P, that is x, y, z and t, as well as x dash, y dash, z dash and t dash respectively. In order to obtain the relation between these, again we will complete this vector triangle already that has been given here, or you can trace here in this way that these are two frame of references which are inertial in nature. The Galilean transformation what we are discussing here, that is valid for the inertial frame of references only, and initially at t is equal to t dash is equal to 0, this s dash was coinciding with s, and O dash are observing about the this p at this one, as well as for s dash, y dash, z dash and t dash. These are the information. Since this information has been measured or revealed by O, that's why we will write it as R. This has been measured by O dash, that's why it is R dash, and this has been the distance traversed by S dash in a time t with a constant velocity v. So let us have the relation between them. That relation can be given in this way, that R dash is equal to vector R minus Vt. Here since V is only along x-axis, here you will see along x-axis, there is no motion along y-axis as well as along z-axis. That's why if we will write it in its component form, then we will write it as x dash I plus y dash j plus z dash k. This is equal to x I plus yj plus zk minus v into t. This v is only along x-axis, need not to write suffix x here because this is directed or this is concentrated only along x-axis. If we will compare both the sides, then we will write here x dash is equal to x minus vt because this will be only along x-axis. And if we will compare the y component, then y dash is equal to y and z dash is equal to z. One more important thing which I wish to add here in the Galilean transformation equation, that the Galileo considered that there is no need of transformation of the time coordinate. Means that time remains as such as has been observed by O, or that is O dash. Means that t is equal to t dash Rt dash is equal to T. There is no need of any change in the time domain that has been measured by the observer O and O dash. Why he has stated this one? Because in his concept, space and time both are independent to each other. They have to do nothing to describe the relation between T and X, T and Y, T and Z, etc. That's why he put it independently. But in the further lectures, you will see that the time needs its transformation, and that too depend on the space coordinate. Means that this T is not independent, but it was not clear at the level of Galileo. Now let us take the second case. In this case, simple situation is here. Now the frame of reference, that is the second frame of reference, that is moving in all directions simultaneously. Means that we are taking this frame of reference, that is as frame of reference, and here we are taking another frame of reference, and this frame of reference named as S dash frame of reference, that have all the characteristic and all the necessary conditions which have inertial frame of references there. This is known as S dash. Now these two coordinates means that these 2 points, this is corresponding to O, this is corresponding to O dash, and if we are saying that this point P is here, then again we will have the X, Y, Z and T, X dash, Y dash, Z dash and T dash here. And in order to have the relation between these coordinates, in this way, let this point is here, then we will complete this vector triangle, and again we will write it as this is R, this is R dash, this is O dash, this is equal to VT only. And if we will have the relation, then here this V is not only along X axis, this is in all directions simultaneously. That's why we will have Vxi plus Vyj plus Vzk. Is that this Vx, Vy, Vz are the component along X direction, along Y direction, along Z direction. Now if we will have the relation between the different component, that is X and X dash, Y, Y dash, Z, Z dash and T, T dash, need not to transform T, because already Galileo has stated that T dash will be equal to T because it is independent to the space. Now we will write here X dash I plus Y dash J plus Z dash K, and this will be equal to X I plus Yj plus Zk, and minus sign. Here we will have Vx T, you can say that this is Vxi plus Vyj plus Vzk, and this will be multiplied by T. And if we will compare X dash, Y dash, Z dash, then we will have X dash is equal to X minus Vxt, Y dash is equal to Y minus Vyt, and Z dash is equal to Z minus Vzt. This will be the relation. Again, the time coordinate will have no change. That's why this T dash is equal to T. So these are the Galilean transformation equations has been suggested by the Galileo in order to define the relation between the coordinates observed by the observer by being in the static and moving frame of reference. under the condition of inertial frame of references. Now, in order to measure the things which are universally lying in this universe, universally lying means that if we wish to measure the speed of light, we wish to measure the motion of Earth, we wish to measure the motion of other planet also, that there must be a particular frame of universal and with respect to which all the measurements can be carried out. So for that, scientists were very much excited to see the concept of the motion of mechanical wave that need a medium. Similarly, they extend the concept for the propagation of the light also, and they define that if light is coming from sun or from star to the earth, then there must be a medium throughout. And in order to have that medium, they consider that there is the universal ether medium, means that this entire earth and all the universe has been dipped in a ether medium, and that may be considered as the universal frame of reference, and with respect to which even at the speed of light, even the speed of earth and other planet and satellites can be measured. So what was the concept for this luminiferous ether medium? For the propagation of the light and other electromagnetic waves in the free space, and hypothetical ether medium has been proposed by the scientists. And what the characteristic this ether medium may prevail, that has been suggested by our scientists. Let us see carefully here. That medium should be perfectly transparent, perfectly non-resistive. That should be constant, continuous and stationary, solid like steel, having very high elasticity and negligible density. Although it's very difficult to possess all these properties, before that we have the massless, that should be rigid, that should be invisible. All these characteristics should be there with the luminiferous ether medium, although these characteristics are very difficult to achieve for a single thing what they were proposed as a luminiferous ether medium. All the objects including the earth, moon, star, etc. may move freely through the hypothetical ether medium without any disturbance. Thus, it may be concluded that ether provide a universal fixed frame of reference or absolute frame of reference with respect to which all the measurement can be done. It was suggested by the scientists, but very soon when it has been analyzed by the different other group of scientists, then else definition or else situation has been observed by them. Before that, let us see that what happened if the absolute ether medium or this frame of reference was suggested. Let us have this particular interesting picture here. For example, this man is in a rocket and this light flash is here and one person is here at the surface of Earth. Now the question is here, what will be the relative velocity between V and C? If that has been measured and realized, then the relative velocity between the earth and ether has been observed as C minus V. This person who is in rocket sees that the relative velocity is C minus V, and he disagreed with the Maxwell's concept which has been given for the Maxwell's laws of electromagnetics. Now there was a great problem if we are considering this situation, means that universal ether medium is there, with respect to that rocket is there, with respect to the universal ether medium light has also been measured, then there will be the relative motion between them, and that will be c minus b or b minus b, v minus c. Since c is very high, that's why usually it is c minus b. When this concept was used in the Maxwell's suggestions, which has been given for the Maxwell's laws of electromagnetic, then the situation was not in favor of the suggestion one, not in favor of the expressions what has been concluded by the Maxwell's for the laws of electromagnetic. So here we say, if so, this word with a rest frame of the luminiferous ether medium, do Maxwell's equation work only in one frame of reference? When earlier situation was predicted, means that V and C has been taken the relative to each other, then the Maxwell's laws were in trouble. That's why it has been rethought that either the Maxwell's laws are applicable or can be handled, can be applied only in one frame of reference. For that, another view of the same thing is here. If any situation of the relative motion between the earth and ether, as well as between the ether and speed of light will be there, then let us see what the situation is here. Here earth is moving around the sun throughout the year, and this luminiferous ether medium is here, in which this entire universe is dipped. If this situation is prevailing here, for example, this is the stream of light which is coming here, and earth is continuously moving, then one time will come when it will go here, one time will go when one time will it will go here, then when it is here, then its direction of motion in this direction, and the stream of light or the corpuscles of the light is in the same direction. That's why the relative motion will be c minus v. And if we are taking another situation, means that our earth have its direction in this direction, means that it is reaching here, then the relative motion between the c and v will be in such a way that c plus v will be here and c minus v will be here. This is also a big problem, because if the scientists were considering the c plus v and c minus v, then the Maxwell's laws were in trouble at that time. Now let us see what we have learned in this lecture. If we conclude that what the things we have learned in this lecture, then obviously first one point which we realize that we are now able to define the relativity. We can define what is the event, how the same event appear different when the observer from the different position, it has been observed by the different position, and what do you understand by the frame of references, and what are the differences between the inertial and non-inertial frame of reference, what we understand by the transformation equation as well as the Galilean transformation equation. As far as assignment is concerned, you should take these questions as the assignment, that first find the Galilean transformation of position, velocity and acceleration, so that acceleration remains constant under the Galilean transformation, so that the length of a rod remains invariant under the Galilean transformation. If we will see about these questions, then here some more points I wish to discuss regarding to the consequences of the Galilean transformation equation, according to which, let us take first, for example, we are taking the position. Position means that the difference between 2 points. For example, we have this position and we have this position, and obviously it may have its coordinate x, y, z. Better to write x1, y1, z1. Here we are writing x2, y2 and z2. If anybody is to have the difference between these two. Then we will write it as x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, and if we are taking the root of this one, then this may be the f distance between them. Now if anybody is saying that what will be situation when it has been observed by the observer which is in moving frame of reference, then the information will be this way: x1 dash, y1 dash, z1 dash, x2 dash, y2 dash, z2 dash, and we will take the difference of that, then we will have x dash, and that is equal to under root x2 dash minus x1 dash whole square plus y2 dash minus y1 dash whole square plus z2 dash minus z1 dash whole square. And we will have the transformation equation, means that already Galileo has suggested that x dash is equal to x minus vt and y dash is equal to y, z dash is equal to z, and need not to transform the time coordinate according to the Galilean. Here if we will put these values here, then we will have s dash, this is equal to under root x2 dash means obviously that will be here x2 means we are writing here, then x2 minus vt and minus x1 plus vt if we are taking the transformation equation corresponding to the Galilean suggestion, then this will be as such because y2 is equal to y2 dash is equal to y, then y2 minus y1 whole square plus z2 minus z1 whole square. Here these will cancel out, and finally we will have x dash is equal to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This expression is exactly same as this one, and finally we can conclude that s dash is equal to s, means that the length of a rod remains invariant under the Galilean transformation. Actually here we have taken all the directions simultaneously, means that x, y, z, all the coordinates here. But if anybody is saying that so that the length of a rod remains invariant under the Galilean transformation equation, then we will take only the coordinates of this one, means that x1, and here we are taking x2 corresponding to the moving frame of reference, x1 dash, and here x2 dash. So obviously first we will write that x1 minus x2 minus x1, this will be the length of the rod when it is observed by the S frame of reference, and x2 dash minus x1 dash when it is observed by length of a rod observed by the observer in S dash. By putting the values of this one, over right here x2 minus vt minus x1 plus vt, and these two will cancel out, and this is equal to x2 minus x1. This is exactly same as we have observed here. Means that if we are saying that this is L and this is L dash, then we will have L is equal to L dash. This shows that the length of a rod remains invariant under the Galilean transformation equation. Here, what will happen about the acceleration? In order to discuss that, what will be the transformation of acceleration under the Galilean transformation equation, then we will write here, for example, we are write R. This R dash is equal to R minus Vt. This is the relation. If we will write it in a component, then x dash, y dash, z dash, etc. will be there. Let us differentiate dr dash upon dt. This is equal to dr upon dt minus v. Then if in first step we stop here, then we will write here u x dash is equal to u minus v. This is the transformation of velocity component, and it means that how the velocity will change when the things are observed by being in the stationary and moving frame of reference. That has been given here. What will be the Galilean transformation for the velocity? And if we will have further differentiation with respect to time, then d2r dash dt2 is equal to d2r upon dt2, and this will be equal to 0 because it is the constant quantity. And finally we will have a dash. This refers that a dash is equal to a, means that the acceleration of the body remains as such. So these are the points what I was interested to discuss in this lecture. And this assignment you are suggested to do, and you should suggested to complete. And now in the next lecture